When those mobile games first came out, where you can steer by tilting the phone like this, I was really amazed. I thought it's the coolest thing ever. Then I played for like 5 minutes and got bored. But that's because mobile games back then were very basic compared to PC or console games at the time. I still like the idea, so I'm going to teach you how to use the device orientation sensor to figure out the tilt. You can use this to make other games as well, like a friend of mine made Jazzman versus Metalheadz. Check it out, it's on the Play Store. It's definitely not a racing game, but you should be able to code something like that too with what you learned today. You can also make other apps, not just games, like an app to measure heights of trees or distances to faraway objects. I have tutorials on those if interested. But today, at the end of the video, I'll show you how to integrate it in the racing game. So let me steer you in the right direction. Wait, I've used this one before. Let me try again. How about, no.
Gonna code, debug, and have fun. Coding with Radu, coding with Radu. Gonna prototype and design. Coding with Radu, coding with Radu. Let's code now.
I have Visual Studio Code open in an empty folder, and let's create our first file, index.html. And we begin with basic HTML syntax, first the doc type, and then the HTML tag, and in it the head tag, and the title tag. The title today will be Phone Tilt Experiment. Like so. And in the body, we're gonna add a canvas element. We'll visualize the phone sensor's values on this canvas. Now save this file and let's open it in a browser. I'm gonna use Google Chrome, and you can see the title appearing here. And if you open the developer tools, you can see the canvas is also here. It's just transparent at the moment. So let's give it some styles. Here in the head section, I'm gonna open a style tag, and in it, give a style to canvases. So a canvas is going to have a background color of orange this time. And if you save and refresh, you're gonna see this canvas appearing orange now. Let's move it in the middle of the screen. For that, we're going to give it a top of 50% and the left of 50%. Now, these won't affect by themselves. We also set here position to absolute. And now we get the canvas in a new position. It's not quite in the center of the screen, but its top left corner is. So we need to translate this by half its width towards the left and half its width towards the top. We do that like so. Translate minus 50%, minus 50%. And now we get this. I want it to be larger to fill my space better here. So I'm going to go down here and say a width of 700 and a height of 500. Now, I'm not adding these as CSS attributes here because I want the canvas itself to be this size. I don't want it to just look that size, if it makes sense. So now if you refresh, you're going to get something like this. And let's draw an ellipse in the middle of the canvas. For that, we're going to use JavaScript and we need to reference this canvas. Somehow I'm going to give it an ID of my canvas. And let's define a script tag here. And the first thing we do is get a reference to the canvas context. So CTX is the 2D drawing context of the canvas, which we use to draw our ellipse. We do that here. Let's scroll down a bit and begin a new path. Now, the ellipse method in this canvas context has many parameters. The first one is the x, the center of the ellipse. So I want this to be in the middle of the canvas. The second one is the y value. So also in the middle vertically like this. Now, the third and fourth are the radii. The first is the horizontal radius and the other is the vertical one. Let's just put here 150 for now. And the next parameter is the rotation. The ellipse can also rotate if you want, but I'm just going to put it to 0 for now. And then the last two parameters are saying that we want a full ellipse. So starting at 0 and going all the way to 360 degrees. But we are working with radians here, so 2 pi. And now we stroke. Save and refresh, and you're going to get the ellipse showing on the canvas now. Let's play a bit with that rotation. So I'm going to go up here and define a rotation variable. Let's set it to 45 degrees or a quarter pi and put this rotation here as the fifth parameter. Now if you save and refresh, it's going to look like that. And let's animate it. Let's make it spin. So I'm going to go here and create an animation loop. Let's start by calling animate. We need to implement this function here. So animate is going to increase this rotation on every frame and then draw the ellipse at the new rotation like so. And right before we close this curly brace here, we need to call request animation frame, passing animate here as the callback function. So this is going to call animate again and again and again, many times per second. Now, if you save and refresh, you're going to get this crazy thing. Let's see it again. There are many ellipses there filling up this donut shape. Interesting, but it happens because we're not clearing the canvas on each frame. So let's do that here and say ctx clear rect, starting in the top left corner. So 0, 0, we cleared the whole canvas. So passing the width and the height. Now if you save and refresh, you're gonna get this other crazy thing. And that's because we're increasing the rotation really quickly here. 1 radian is a lot, so we could increase by a smaller value here, like so, and get a smoother animation. But really, we want this to connect to our phone's sensor. So I'm going to teach you how to do that. We're going to implement phone controls next. And let's define these controls as new phone controls. And we have to code these ourselves. So here we do it in a separate file. I'll call it phone controls.js. And let's close the script tag. If you control click on this in Visual Studio Code, it's going to create the file. And we're going to start typing the phone controls class. Phone controls. And in the constructor, one thing we need to keep track of is the tilt, how much we're turning the phone. Let's define this as 0 in the beginning, and now add some event listeners that change it depending on what the sensors say. We'll do this in a private method here, that's why the hashtag in the beginning. And we will add an event listener to the window, listening for device orientation. And the callback function takes one parameter. Let's call it E. And let's now put the body of our function here. And remember to close this parenthesis as well. And inside, I'm just going to log what E is. So logging E, save and refresh. Everything is still the same now, but in the console, you will see one log appearing here. Now, testing your phone on the computer can be challenging, so these developer tools have a way of simulating that. You have to go up here, more tools and sensors, and in this second section called orientation, you can choose portrait, for example, but you can really play with this thing on the right here and see those numbers, the alpha, beta, and gamma, are all changing. You can study them if you want, but for this racing game, like steering like this, we are going to use the beta angle. Look what happens when the phone is horizontal like this. The beta is almost zero, pretty much. It's zero if I could put it there perfectly, but I can't. So this means don't steer. And if we're going to tilt the phone to the left like this, we get higher and higher beta values, but negative. And if we do the same thing on the right like this, it's going to be positive values. So this beta really tells us how much we want to steer left or right. Let's put here this tilt is equal to e dot beta, and I like converting these into radians because most of the things in JavaScript are in radians. You always want some kind of consistency when writing code. Now, back in index.html, instead of updating the rotation like this, we could just set it to be equal to the controls tilt. And that's it. Now, if you save and refresh, it doesn't spin anymore. And if you're gonna move this device like so, you can see it controls that. We can test on the phone as well if you host your application on something like CodePen or if you have your own website. And let's see what happens. So now if I'm tilting, I would like this ellipse to stay flat, really. All the game contents should be flat so that you don't get confused when rotating the phone. Basically, we want the ellipse to go in the other direction. And we could do that by just saying here is equals to minus the controls tilt, but we don't want just the ellipse or the car to go the other direction. We want everything to go in the other direction. So we don't really want the ellipse to rotate. I'm gonna remove this change in the rotation here and pass the canvas to the phone controls themselves. So the phone controls will be responsible to rotate the canvas in the opposite direction, basically. Let's go to phone controls here and pass the canvas, store it as an attribute. And here we can define the canvas angle to be minus this tilt. And now we can give a new style to the canvas, a new transform style. And when doing this, it's important to remember that the canvas already has a transform style, this translate. So let's start with that and say translate minus 50%, minus 50%. But now we also give it a rotate by this canvas angle. And let's make sure these are in radians here. Now if you save and refresh, let's make this ellipse level. So remove the rotation here, set it to 0. Save and refresh. And now when rotating the device here, that's what happens. And it's a little bit confusing here, but on your phone, it should be fine. Turning to the left is going to keep the ellipse looking flat pretty much. Now, it's not perfect. It also depends a little bit on this other angle that you keep your phone at. And actually, if you keep your phone upside down like this, it goes completely crazy. And you could fix this by typing a lot of code, but I like to use a different method here. One I wanted to show you in that live stream I made with the candles, where the flame should be pointing up, but I didn't have enough time. So I'm going to teach you about it here. And we are going to copy this code like so. And I'm going to comment out the top version and leave it here just for your reference. But what we'll do is we'll use a different parameter here. We're going to listen for the device motion event. And this is going to be a little bit different, and I'll explain in a second. But first, let's type here, instead of beta, the arctangent of E dot acceleration, including gravity dot y, and acceleration, including gravity dot x. So the only thing we change is the way we measure this tilt. And now if you save and refresh, this doesn't work anymore. The developer tools don't work with that device motion event. But if you can test on a device like this, then it is going to be better. Now, the phone has a coordinate system of itself. The x and y axes are here like this on it. So if the phone is flat, then gravity is not pushing on x and y. It's only pushing on z. But if you hold your phone like this, if it's perfectly vertical like so, then it's going to push on x. And if you tilt it like that, it's going to push on y as well, depending on how you tilt it, really. So from the top view, what we want to calculate here is the angle that you can see here, formed by this pull of the gravity on the x and on the y together. Hope that makes sense. For me, it's the simplest way to do this, and it works quite okay, but it is a little bit fidgety. Like, the signal is noisy a little bit. And we can fix that in a number of ways. For example, we can go here at the top and define the canvas angle as an attribute, set it to 0. And here, instead of canvas angle is equal to that, we say the new canvas angle is equal to that. And we check to see if this new canvas angle and the old one are different enough. So if the absolute difference between the new canvas angle minus this canvas angle is greater than 0.2, for example, we are going to set this canvas angle to the new canvas angle. And let's remember to have this dot canvas angle here. Now, if you save and test on your phone, you're going to see that it's not anymore fidgety, but if you rotate it, it's jagged somehow, and we don't really want that. We want this to be smooth. So my preferred way of solving this is to remove this if entirely and just update the canvas angle with respect to its previous value. So this canvas angle times 99% of the value is going to come from here, and new canvas angle, just 1% comes from that. And let's see what happens. Save and test on your phone. And it's definitely smooth, like really, really smooth. Not really good when you want this to be a racing game. So play with these values a little bit, see what works for you. I like to use 0.6 and 0.4 here. I think they work for me. And you just learned how to make a bubble level app. You're welcome. Now, let's start integrating these controls into the racing game. For that, we need to remember that the car doesn't just steer, it also needs to go forward and in reverse. And you can take it as a challenge. Maybe try implementing that you go forward by tilting like this, kind of like pushing on the pedal, and maybe even control the speed, the acceleration like this. But I'm just going to make very simple interface here. So touching the screen means brake. And if you don't touch the screen, it's just going to go forward by default. So this forward is true. This reverse is false. And down here, we need two new event listeners. One for, I'm going to use touch start. And here I'm going to set this reverse is equal to true and this forward is equal to false. And now let's copy this again with touch end. And these like we had in the beginning here. So like that. And let's take this code into our self-driving car racing game code base. This is the code base. You can get it from the link in the description if you don't have it already. And I've added here our phone controls that we just implemented. Now, this is going to be a new version of the game. So I like to copy race HTML and rename it to phone HTML. So this phone HTML is going to be the same thing, but we're going to be controlling the car with the phone instead of the keyboard. And first thing we need to do here above this camera.js, I'm going to include phone controls. And to make the car listen to these new controls, I'm going to go down here and add a script tag where I just say my car controls is new phone controls on the camera canvas. So we already have one where it shows the camera view and camera canvas here. Now, this is not enough. We also have to tell the car to use that tilt in some way, because at the moment it doesn't. If we look here in car.js and go to the move method, it checks if controls left and right are pressed and changes the angle with respect to those. But what we'll do here is if the controls have a tilt, then this angle is going to be minus that tilt. We use minus here because the car uses a little bit different reference frame. And here, else, everything as before. So we make this code backward compatible. And that means that we can still have the version controlled by the keyboard and this other one controlled by the phone as well. Now let's save this and open phone HTML in the browser. And we get this because this camera canvas is now just translated by half its width and height from this. We also need to move it to 50% top and left. I'm gonna go to phone HTML at the top and just add here some inline style. So style is equal to, and let's do this on several lines, top 50% and then left 50% and position absolute. Now save and refresh, and we're going to get this. Now I can't test on this website. Maybe just clicking on it to break, which doesn't actually work because we're using that touch start event listener. We need to be on a phone, and you could simulate a phone like this. If I press and hold and press and hold and press and hold, it does detect this gesture. But I find these really confusing here because this screen is so small and my phone is even smaller. So I'm just gonna hide these elements for this version. You can think how to make them look nicer if you want, but I just put here display none for the minimap canvas and also for these statistics. And this is cleaner now. Let's test also on the mobile phone. And you can actually see that it works, but in a strange way. What we're doing at the moment is we are just setting the car's rotation angle to whatever the phone is. And we don't want that. We want to just control the steering by the tilt instead. So this now it works in some funny way, but it gives us a lot of control, and we sometimes have to hold it upside down and crazy stuff. It's not good for the racing game. So we do that easily. In the car.js, we just update this angle. So instead of equal to, minus equals, this controls the tilt, and we multiply by some small value. I'm just going to try with this 0.03 since we have it here already. Now save and test on your phone. And everything seems to work. It's a bit slow though. My phone is not very good, so I definitely sense lag in it. I'm gonna strip this down a little bit, try to make it more efficient, and host it on my website so that you can test it there if you don't have some other way of doing it. I'll also add this snippet here for making it work on full screen. So you have to tap the screen when you start the game, and then you're gonna see it like this. It also activates the sound like that.